All right, if you haven't done the 5-minute check yet, let's take a couple minutes and do the 5-minute check. So go ahead and pause the video while the students complete the 5-minute check. All right, so let's see how you did. In Maz's second period class, 10 students went to Florida for spring break, 5 went to Michigan, and 6 stayed in Perrysburg. If a person selected at random, find each probability. What's the probability that a student left Perrysburg? So going to Florida or going to Michigan both count. So 10 plus 5 makes 15 out of the 21 students left Perrysburg, so that's 71%. Second one, the probability of going to Michigan or Perrysburg. So Michigan is 5 and 6 is Perrysburg, so we get 11 out of 21, so 52%. Okay, so this is basic probability, but today we're going to talk about the addition rules for probability. All right, so the addition rules are used when we see the word or. So really, left Perrysburg means went to Florida or went to Michigan. So that does represent an or. So really our lesson today is about or. Probability when you're dealing with or problems. Okay? So going to, let's talk about some ors. Okay? The question says, how do you find the probability if the events are mutually exclusive? Now, that's difficult to answer if you don't know what mutually exclusive means. So let's go to the Cornell sheet and define a couple things here. The first one, when we talk about or, okay, one thing we should understand about or is that when we're doing an or problem, we are always going to add the probabilities, just like you added the number of students that went to Florida and the number of students that went to Michigan to find leaving Perrysburg, or when you added the probability, the number of students that went to Michigan and the number of students that went to Perrysburg or stayed in Perrysburg, we added those together to get 11. So anytime you see an or, you're going to add. And it's easy. What we just did were two mutually exclusive events. So a student could go, either has to go to Michigan or stay in Perrysburg. According to the way this problem is written, you can't do both. So mutually exclusive, if we define this, it's actually the definition's all the way at the bottom of the Cornell sheet. So mutually exclusive events, also called disjoint, are events that cannot occur at the same time. So, for example, you can't be even and odd at the same time. You are either even or you're odd. So, for example, even versus odd. Okay, these are mutually exclusive. You can't be even and odd at the same time. However, I guess if you consider 0, but most people consider 0 as an even number. So another one might be, at this moment in time, you can't be in Perrysburg and Michigan at the same time. Those are mutually exclusive. Okay. Now the opposite of that would be, let's flip to the back side. Inclusive events, also known as non-mutually exclusive. Okay, and these can also be called joint. So these are all words that you might use to represent events that can occur at the same time. Events that can occur at the time. For example, the probability of a 2 or an even. Okay, so you could have a number that is a 2, and you can roll a number that is an even, and it can be a 2 while being an even at the same time because they overlap. So for example, here are all the 2's, here are the evens, and they do overlap. They actually overlap at one single number. So it might be they overlap at one number, which is 2, because the 2 fits inside the even. So really a better drawing of this would be where this is the evens and the 2's right inside. You don't need to worry about that, okay? You just need to know that those things can both happen at the same time. A number can be a 2 and be an even at the same time. So let's talk about what we do once we know if they're mutually exclusive or not, okay? So you'll see the or, and the or will tell you to add. Now, if they are mutually exclusive, which means 2 completely separate things. So, for example, going to Peaburg or being in Perrysburg and being in Michigan. You can't do both of those at the exact same time. So they are separate. They're exclusive from each other, separate from each other. So if you wanted to find the probability of being in Perrysburg or Michigan, you would take the probability of being in Peaburg or MI. You take the probability of being in Peaburg and you would add it to the probability of being in Michigan. Okay? Or for example, if you want a probability of A or B, that's the probability of A plus the probability of B. Okay? That's if they are separate from each other. Okay? Now, if they are inclusive, then you have to do one extra step. So let's talk about the probability of, let's see. Okay, so let's do the probability of being in Perrysburg and the probability of being in Ohio. Okay, now this would not be the best way to draw this because the one is going to be inside the other. So let's fix this. I just made this. So let's say here's Ohio. Perrysburg is going to be inside there. So they're going to have overlapping. So what we would need to do is find the probability of Perrysburg, Peaburg, or Ohio would be the probability of Peaburg plus the probability of Ohio minus the probability of both. Okay? And so we can write it with A's and B's. The probability of A or B would be the probability of A plus the probability of B minus the probability of A and B. Okay, let's look at some problems so you can understand. It'll make more sense when I do a real problem for you. So let's talk. All right. A dice is rolled. What's the probability that you roll either a 2 or an even number? So if we want to find the probability of a 2 or an even, then that's going to be the probability of 2 plus the probability of an even. But we can't just add them together or we'll add some of them more than once. So then we have to subtract the probability of being 2 and even, or subtract the overlap. Okay, so here's the deal. If they overlap, so mutually exclusive don't overlap. Inclusive overlap. One includes the other. So if there is an overlap, then you have to subtract the overlap. So the probability of getting a 2 on a regular die, there's only 1, 2 out of 6. Okay. The probability of an even, well, out of the 6, 3 of them are even. And then we need to subtract the overlap. So how many times could it be a 2 and an even number? Okay, there's only one time when it will be a 2 and an even number, which is 1 over 6. So we add these probabilities together, which gives us 4 over 6, and we subtract the overlap, which is 1 over 6, and that gives us 3 out of 6, which is 50%. So there's a 50% chance that it's either going to be a 2 or an even number. Let's try another one before you ask any questions. Number 2 says a survey of college students found that 56% live on campus, 62% participate in the campus meal plan, and 42% do both. Okay? So if we want to find the probability of campus plan or meal plan, they live on campus or have a meal plan, want to find the probability of living on campus, add it to the probability of the meal plan, and we need to subtract the overlap. Let's write overlap, or both. So the probability of living on campus is 56%. The probability of having a meal plan is 62%. And we have to subtract the overlap because 42% of them do both. So if we don't subtract the overlap, then you'll be counting some of these people twice because some of these people have the campus, live on campus, and have a meal plan. So we have to subtract the overlap so we get an accurate number. So we get 0.76 or 76%. Okay. All right, now we're mixing these together and then we're going to look at some two-way tables also. So it says during a magic trick, a magician randomly draws one card from a standard deck of cards. Find each probability. Probability of a heart or a diamond. So I want you to think about it this way. We always are going to do the probability of the one plus the probability of the other, and then we're going to subtract the overlap. So the probability of choosing a heart, if you're not great at cards, there are 13 in each suit. So there are 13 hearts out of 52 cards. The probability of choosing a diamond, there are 13 diamonds as well out of 52. Now it's impossible to be a heart and a diamond. A single card can't be a heart and a diamond. So when you go to subtract the overlap, you just subtract nothing. But sometimes I consider all of them as inclusive so that I'm always looking for a place where they overlap so I don't overlook that. So we just add them together, which gives us 26 out of 52. And that's 50%. Okay. Now let's look at the next one. The probability of an ace or a spade. So we take the probability of an ace. How many aces are in a deck? So probability of an ace plus the probability of a spade minus the overlap. Okay, so there are 4 aces in a deck, 4 out of 52. And the spade is just another suit, which again, there are 13 in every suit, so plus 13 out of 52. We need to subtract the overlap. Is it possible to be an ace and a spade? Of course. So you can have it be an ace and a heart at the same time. You can be an ace and a spade, but there's only one card in the whole deck that is an ace and is also a spade. So we need to subtract that one or he gets counted twice, and then our probability won't be accurate. So we end up getting 16 out of 52 instead of 17 out of 52, which is 31%. So it might be good to always consider subtracting the overlap. And that way you're always looking for it in case there is an overlap. Number 4, now we're going to use a two-way table. Table shows the breakdown of nurses and physicians in a hospital unit. Find each probability. Move on down here. So the probability that the person chosen is a nurse or a male. So again, probability of nurse plus probability of male minus overlap. Okay. So probability of a nurse, there are 8 nurses out of 13 total. Probability of a male, there are 3 males out of 13 total. And the overlap, so a nurse and male. male nurse. So there is one male nurse, so we have to subtract that one overlap. And so we end up getting not 11 out of 13, but 10 out of 13, which is 77%. Okay. I want you to do B on your own, so we're going to pause it. Pause the video here, and I want you to do B. All right, let's see how you did. So probability physician or a female. Remember, this is all based on the or. So we do probability of a physician plus probability of a female minus probability of physician and female. So probability of choosing a physician would be 5 out of 13. Probability of choosing a female would be 10 out of 13. And the probability of choosing a physician that is female would be 3 female physicians. So we subtract 3 out of 13. So this time there's 3 people that would get counted twice if we don't subtract the overlap. So that gives us 12 out of 13, which is 92%. So mutually exclusive means they don't overlap, so you don't have to subtract anything. But if they are inclusive, they do overlap and you have to subtract. So 5 says a student is selected at random from a group of 12 males and 12 females. There are 3 males and females from each grade. Find each probability. Now it might be helpful, very helpful, to make a little chart here. Okay, so we're going to squeeze it in at the top. Now, not every question is going to ask for a chart or give you a chart, so sometimes you might have to make one on your own just to organize everything. So we have males and females. Now we've got 9th, 10th, 11th, and 12th. Now it says there's 12 males and 12 females. There's 3 females and 3 males from each grade. So this is what the chart looks like. Okay. So we know there's 24 total because 12 males and 12 females. So when we add up, we get 12 here and 12 here, which gives us 24 total. So the probability of being a 9th grader or a 12th grader. So 9th graders, male and female, that's 6 out of 24. 12th graders, that's also 6 out of 24, minus the overlap. Now, can you be in 9th grade and 12th grade? Sorry. You cannot be in 9th grade and 12th grade at the same time, so there's no overlap. So we just add these together, 12 out of 24, which is 50%. Okay. B, probability of 10th grade or a female. So I want you to try B and C on your own. So we're going to pause the video again here and have you try this. Use your chart up here to help you. Pause it now. All right, let's see how you did. So probability of being in 10th grade, which is still 6 out of 24, plus the probability of being a female. So all the females is 12 out of 24, minus the probability of being in 10th grade and being a female. So that would be 3 out of 24. So we get 15 out of 24, which is 63%. How did you do on that one? Let's talk about C. Probability of male or female. Probability of choosing a male student would be 12 out of 24. Probability of choosing a female student would also be 12 out of 24. And you subtract the overlap, which is none. You're either one or the other. So then we end up with 24 out of 24. So there's a 100% chance that if you pick a student at random, they are either male or female. And some of you probably figured that out before you even made any fractions here. So excellent for you if you did. All right, next, a Venn diagram. These can be tricky, so you need to be careful. Carbon monoxide detector system uses 2 sensors, sensor A and sensor B. If carbon monoxide is present, there is a 96% chance that the sensor A will detect it. There's a 92% chance that detector B will detect it, and 90% that both sensors will detect it. The first part says we're going to draw a Venn diagram that illustrates the situation. So we've got detector A and detector B. Now we want to start first with this. It says there's 90% chance that both sensors will detect it. So this overlapping place is where both of them fall in. So there's a 90% chance that both of them will detect it. That's where they overlap, okay? Now, if overall there's a 96% chance that sensor A will detect it, okay, that means in the entire circle should be 96%. Now, we already have 90% accounted for within this overlapping region. So then there should be only 6% left over here, because the whole circle has to be 96% to represent that detector A would sense it, okay? We do the same thing for the B. Now, if detector B is 92% chance and 90% is already accounted for in the overlapping region, then we have only 2% left over here. So what does that mean? So what that means is that there's only a 6% chance that only detector A will pick it up. There's a 2% chance that only detector B will pick it up. And then there's a 90% chance that they will both pick it up. But again, overall, there's a 96% chance that the A will pick it up. And there's a 92% chance that detector B will sense it. So you want to make sure you put the both in the middle first and then subtract to get the leftovers there, okay? We could, let's go to your Cornell sheet and write something down here. So let's go here, Venn diagram. Okay. So this is where you put both, okay, where they overlap. And then you need to subtract to get this one and subtract to get this one, okay? But you always begin first with putting the both in the middle and then subtracting to find the onlys, okay? So again, that circle means that only A picked it up, and this circle means that only B picked it up, okay? Only A, all right? So let's answer these questions. If carbon monoxide is present, what's the probability that it'll be detected by A or B? So we can go back, there's a couple ways we can do this. Go back to the formulas that we're using here. So A or B, that'd be the probability of A picking up would be 96%, plus the probability of B picking up, which is 92%, minus the overlap, which is 90%. So when we add those together, there's a 98% chance that A or B will detect it. A or B, okay? The other way you can think about it is A or B means anything in A or anything in B. So the other way you can do it is just add 6% plus 90% plus 2%. And that will also give you the 98%. This is probably the safest way to go, especially if you don't make your Venn diagram correctly. And this also just goes along with exactly what we did in all the other problems. So add the two probabilities together and subtract where they overlap. Okay. What's the probability it will go undetected? Well, if 98% of the time either A or B will pick it up, then we just subtract that from 100. So that means that there's only 2% chance that neither of them will detect it. And that's all I have for you today. Have fun.